Welcome to our AI project in the domain of engineering. The domain that we do is the electrical engineering, to be specific, power systems. So, right into the reading project. In electrical engineering, it's a fundamental thing to generate, transmit, distribute, and utilize the electrical power and the electrical devices connected to such electrical powers like generators, motors, transformers, mixing, grinder, anything. This important subdivision under electrical engineering is called as power systems. As we all can see, power systems involves huge amount of variables such as inductors, capacitors, and resistors, which often play in mathematical equation in a form of higher order differential equations. To solve these, even with computers, it's very tedious to write codes for every simple and individual situation. Since we can see it's very complex, versatile, and large amount of information is needed for calculation, diagnosis, and learning. This increases the computational time exponentially, and the accuracy is very tough to meet due to the extensive and the vast system data handling. The reading project will cover AI ideas like expert systems, artificial neural networks, fuzzy logics, and genetic algorithm. Expert systems. Expert systems is similar to the one that we discussed in our previous reading project. This mimics the human life, the human brain. Decision making is almost a breathing like activity in human life. This is captured and implemented in AI as expert systems to solve problems involving incomplete information or large amount of complex knowledge. Expert systems involve symbolic and rule-based knowledge that relate situations and actions, and they also have the ability to explain and justify a line of reason. Many areas of applications in power systems match the abilities of expert systems like decision making, acting knowledge, solving problems by reasoning, heuristic, and judgments. These are very important in a day-to-day life, but yet we don't even care to mind it because it's so subtle and so intuitive in a human nature. These are taken from the human nature and tried to be implemented as expert systems. Expert systems are very useful, especially for problems when a large amount of data and information must be processed in a short period of time. Now let's see the parts and the working principle of expert system. As we all can see, this is in the reverse order as a user will see the expert system. A user interface is the outermost and the polished surface of the expert system. The user interface will try to accommodate two important factors. One, the rules and facts, and the other, the advice and consultation. Rules and facts composites of three important bases. One is called knowledge base and the rules base. Knowledge base is the data that is provided by the coder. Rules base is the if-else conditions which has been identified from the previous solvable examples. Inference base simply searches for the best possible answer and matches for the query and provide them with explanations and facilities such a way that advice and consultation is made. How expert systems are used in power systems. Since expert systems are basically computer programs, the process of writing codes for these programs is far simpler than actually calculating and estimating the value of these parameters used in generation, transmission, distribution, and utilization. Any modification, even after design, can be done very easily since they are only computer programs. Virtually, estimation of these values can be done, further research can be done, and increase the efficiency of the process can also be performed. Disadvantage is lacks the ability to learn, adapt for new problems and situations. Now let's see about the artificial neural networks and its implementations in power systems. For decades, biological neuron firing in our brain has been of interest to computer scientists. This is implemented in artificial neural networks. Thus, they are biologically inspired systems which convert a set of inputs into a set of outputs by a network of neurons, where each neuron produces one output as a function of inputs. Unspecified nonlinear functions are quite normal in power systems. It has to be encoded. This is done by power systems by artificial neural networks. Artificial neural networks can be particularly also useful for problems which require quick results, like in real-time operations.
ANN in power systems. The problems in generation, transmission, and distribution of electricity can be fed to the ANNs so that a suitable solution can be obtained. Given the constraints of a practical transmission distribution system, the exact values of parameters can be determined. For example, the values of inductance, capacitance, and resistance in a transmission line can be numerically calculated by AMN, taking in various factors like environmental factors, imbalancing conditions, and other possible problems. Also, the values of resistance, capacitance, and inductance of a transmission line can be given as inputs. Combined normalized value of the parameters can be obtained. In this way, skin effect and proximity effect can be reduced to a certain extent. Fuzzy logic. Fuzzy logic or fuzzy system are logical system for standardization and formalization of approximate reasoning. It is similar to human decision making with an ability to produce exact and accurate solution from certain or even approximate information and data. Fuzzification provides superior expressive power, higher generality, and improved capability to model complex problems at low or moderate solution cost. Fuzzy logic allows a particular level of ambiguity throughout an analysis. Fuzzy logic provides the conversions from numerical to symbolic inputs and back again for the outputs. Fuzzy logic controller. Simply put, it is a fuzzy code designed to control something, generally mechanical input. They can be in software or hardware mode and can be used in anything from small circuits to large mainframes. Adaptive fuzzy controllers learn to control complex processes much similar to as we do. How fuzzy logic is used in power systems. Fuzzy logic can be used for designing the physical components of power systems. They can be used in anything from small circuit to large mainframes. They can be used to increase the efficiency of components used in power systems. As most of the data used in power system analysis are approximate values and assumptions, fuzzy logic can be of great use to derive a stable, exact, and ambiguity-free output. Genetic algorithm. Genetic algorithm is an optimization technique based on the study of natural selection and natural genetics. Its basic principle is that the fittest individual of a population has the highest probability and possibility for survival. The genetic algorithm can be differentiated from other optimization methods by genetic algorithm works on the coding of the variable set instead of actual variables. Genetic algorithm looks for optimal points through a population of possible solution points and not a single point.
So far we've looked at the different techniques, the different AI techniques you use in a power system. Now let's look at how all of those techniques are put together in a practical scenario, alright? So consider a practical transmission line. In this line, the fault diagnosis responsibility is given to the fuzzy system, and the three line currents are given as input, and it calculates the difference between two different timestamps, and that is given as input to the fuzzy system. And since this, faults are usually very approximate in power systems, so so a system that has a fuzzy base uh, actually has a very good prediction rate on this kind of fault diagnosis scenarios. So this is what the system block diagram looks like, and this is our entire fault diagnosis system. I mean, pretty much. So this is a fuzzy system which handles the input and the output. The function of expert systems and ANN is that they improve the system as time goes by, right? Because faults change with different climate conditions or different load line lengths and so on. So ANNs and expert systems do that. What expert systems do is that they take all the environmental input and give that to ANNs, and ANNs, according to the environmental input and all the other variables that usually change, based on that they
they decide what the parameters of the fuzzy system should be. So that's how this works. This improves this fuzzy system, and overall it is easier to calculate where the faults are and they can be rectified immediately. And basic ANN training, they're trained to change the values of line parameters over a given range, and you can change those values if you're not satisfied. Basically all the advantages of ANNs comes along with the system as well, right? Because you don't need human supervision after you've put the system in place. It identifies the fault and corrects it itself. It varies all the parameters by itself, so it doesn't need a lot of human supervision. And that's the whole point of including AI in a project. It makes our lives a lot easier, so that's what this does. So not only that, so after we saw a practical power systems application, it has a lot more applications as well. The few major ones are in operations and controls. Control is technically what you saw: expert systems output and fuzzy systems. These two majorly are used for controls of a power system. And during operation as well, to improve the operations, we use ANNs and all of those, because that's what determines how the power is managed, how much load is to delivery, all of that ratio. It pretty much streamlines the entire system, right? Instead of a fixed non-changing whatever initial input we give, the system itself corrects itself. It iterates through all the different inputs till we get an output that we are pretty satisfied with. And distribution systems are another major application of these four techniques that we discussed so far. Planning and operation in the demand side response, demand side management, operation control of smart grids, and network reconfiguration. Not only this, there's a lot of forecasting involved in power distribution as well, because a grid cannot constantly supply power to one thing continuously. So a grid has a particular cutoff point, or a maximum. At any point it can output a maximum of this much load, right? So that load is distributed between different sectors of a city, or things like that happens a lot. That's how power transmission works. And this AI system can help in that aspect as well, because once it learns, because it's basically you give it an input and it gives an output, right? So that input and output depends on various factors: how much demand is actually being taken on an average throughout the day on each part of the city. So based on that, the system can learn that and then improve upon all of this and make sure the output it's giving is accurate. So these are the ways in which AI can be used in power systems. So hopefully we've covered all of the different aspects, all of the different advantages that AI has. And the reason we've used all of these 4 to 5 techniques combined is that some of these have disadvantages, and all of these others put together, they help cover those disadvantages, making this entire system robust. So that's pretty much the point of this project. Thank you.